In this video, we will be doing question 1.1 of this grade 10 CAPS final exam paper. Question 1.1 covers all the types of factorization you are required to know for grade 10 CAPS mathematics. We will cover 1.2, which is about simplification of expressions, and 1.3, which is almost like a solve for X type of question, in a separate video because I don't want the video to be too long. In case you are wondering, how can the video be too long for small Nyana marks question like this? And yes, I know that I also speak quite slowly, naturally, but it's also because my aim is not just to present you with the answers. There are, of course, memos for that. However, my main goal is to equip you with the concepts, techniques, tricks, and tips to work out those answers and thus have a good understanding to solve any similar question and master your coming exams. Anyway, before I bore you with the speech, let's get into the tutorial video. For 1.1, we are required to factorize the following expressions fully. And in 1.1.1, we have an expression that has two terms, 4x minus x to the power of 3. And we can factorize this expression by taking out a common factor because we notice that x is common to both terms of the expression. So we can take x out as a common factor and then we open a bracket to write what is left. And to get what is left, we need to divide the terms of the expression by the common factor. So we will take 4x and divide it by x. And if you do that, you see that what is left is 4. So we will have 4 as the first term inside the bracket. And then we take the second term of the expression, which is x to the power of 3, or negative x to the power of 3, and we divide it by x. Okay? We also divide it by x, and then we can apply the laws of exponents. And well, first thing that we need to take note of is that we are dividing a negative by a positive, so we will get a negative. And then by the laws of exponents in division, if the bases are the same, you write down the base and then you subtract the exponent of the denominator, which is 1 in this case, from the exponent of the numerator, which is 3. And so the answer here is negative x to the power of 2. So we have minus x to the power of 2. And now let's examine what we are left with and see if we have factorized fully. And by the way, this means that if we are multiplying x into the bracket, we must be able to get back the original expression we started with. And so x multiplied by 4 is indeed 4x, and x multiplied by negative x squared is indeed x to the power of 3. So this is correct. But now we have not factorized fully, because if you take a closer look inside the brackets, you will notice that we actually have a difference of 2 squares, because 4 is equal to 2 to the power of 2, and x squared is obviously a perfect square as well. So both of these numbers, or both of these terms that are inside the bracket, are perfect squares, and there is a minus or a subtraction between them. So this is a difference of 2 squares. And therefore we need to factorize this by a difference of two squares. And so we are going to carry x as it is, and then we are now going to have two brackets. And now the first term that is gonna go into our brackets will be the square root of this perfect square, which is 4. So the square root of 4 is 2. So we write 2 and we write 2. And then we go to the second term, which is x squared. The square root of x squared is x, because x multiplied by x is going to give us x squared. And then after this, we just need to have opposite signs within our brackets. So if you write a positive here, you must have a negative there. Alternatively, you can write a negative here and then write a positive into this bracket. Either way is fine. And so this would be our fully factorized expression. And now in 1.1.2, we have a trinomial expression. In other words, an expression that is made up of three terms. We have x squared plus 15x minus 54. And this is a special trinomial expression, which is called a quadratic expression, because it's in the form ax squared plus bx plus c. And so it's a quadratic expression. And we know that if we have a quadratic expression, we can factorize it by writing it as a product of its two linear factors. So inside of each bracket here, we are going to have linear factors of this expression, and their product must give us the quadratic expression that we have. And so you can do this by employing some tricks, and there is a variety of tricks or techniques that you can use to do this, but the concept behind in all of them is the same concept. So for an example, for this particular one, what we are going to do is we'll look for the square root of the first term here, x squared. So if you have x and you multiply it by x, you are going to get x squared. So x is the square root of x squared, and we are gonna write it inside of each term, because it is this product. If you are multiplying x by this x, you are going to get this term back. And now after that, we go to this term here, the constant term c, in our quadratic expression. And we also need to know the factors of 54 that we can multiply together to get 54. And for an example, for 54, we can multiply 54 by 1. 54 multiplied by 1 is going to give us 54. Secondly, what you can do is you can use your calculator and divide 54 by 2 and see what you get. So we get 27, which is a whole number. So this means that if you take 27 and you multiply it by 2, you are going to get 54 again. Let's see if we have got more. So we can take 54 again, and this time let's divide it by 3. Indeed, we also get a whole number again. So this means that if you take 18 and you multiply it by 3, you can get 54. And we can go on just to see if we've got more possible combinations. And this time around, if we divide our 54 by 4, we see that we get now a fraction, we do not get a whole number. This means that 4 is not a multiple of 54 or a factor of 54, so we cannot make use of that. So we can just work with the ones that we have. And so, yes, as you can already see, for 54, we have a variety of options. But now, from these factors, we need to choose one set that we can be able to combine either through addition or through subtraction to get the coefficient of the middle term, which is 15 for our particular quadratic expression. And so, for an example, if we look into the first set, although we can multiply 54 by 1 to get 54, there is absolutely no way on which we can add or subtract 54 and 1 to get 15. So this combination is not going to work for us for the purpose of factorizing our expression. And likewise, if we go to this one, yes, we can multiply 27 by 2 to get 54, but there is no way on which we can combine 27 and 2, either through addition or through subtraction, in order to obtain the middle term 15. So this is also not going to work. But now, if we take a look into the last combination here, 18 multiplied by 3 gives us 54. But in addition to that, if we subtract 3 from 18, we are able to get 15, which is the coefficient of the middle term. And therefore, this means that we can write positive 18 and negative 3 into our brackets. And even here, whether you put the negative 3 into the first bracket and put the 18 into the second bracket does not matter. And so this would be the factorized form of this quadratic expression. And you can test or check whether this is correct or not by expanding your brackets and see if you are going to be able to get your original expression back. And then for 1.1.3, we have here we have an expression that has got 4 terms. We have y minus xy plus x minus 1. And so if we examine all of the terms that are making up this expression, we notice that there is absolutely no factor that is common to all of them. However, you may notice that if we only isolate the first 2 terms here, they actually do have a common factor, and that common factor is y. So perhaps this is what we need to do in order for us to solve this problem. We need to factorize by grouping the terms into pairs. So let's see what we would get if we were to group the terms as follows. And so, as we had already discussed, the first 2 terms here would have a common factor, which is y. So we can factorize these 2 terms by taking out a common factor, which is y. Okay, and then we open a bracket. And now let's see what is left after taking out the common factor. So to do that, as we had already discussed, we need to divide each term by the common factor, which is y. So we divide y by y, and this will give us 1. So we have 1. And then we divide negative xy by y. This y is going to cancel with this y, and we are left with negative x. So we're going to have negative x here. And then these two do not have any common factor. So this bracket is going to remain as it is. Okay? And now what you will notice is that what you have inside your brackets is similar. It's not the same, but it's similar because inside of this bracket here, we have x and we have 1. Even inside this bracket, we do have x and we do have 1. However, the only difference is their signs, because this x here is positive, whereas this one is negative. This one here is positive, whereas this one is negative. So if we could find a way to make the signs the same, then we would be able to factorize once again by taking out a common factor. So here is what we can do in order to achieve that. Okay, what we can do is we can take negative 1 out as a common factor, between these two terms here. So we take negative 1 out as a common factor. So the 1 here is not going to change. We are still going to have 1. Okay? And now if we take negative 1 out as a common factor, we can do it like this. We are going to have negative 1 here, and then we open our bracket. And now, as always, in order to find what is left after taking out a common factor, you need to divide by the common factor that you have just taken out. So in this case, it's negative 1. So if we say 1 divided by negative 1, you are dividing here numbers that have opposite signs. So your answer will be negative, and it will be negative 1. So we are now going to be left with negative 1 here. And then secondly, we have negative x that we are also going to divide by negative 1. A negative divided by another negative will give us a positive, and x divided by 1 will give us x. So we now have positive x plus into x minus 1. And now here, y multiplied by negative 1 is just negative y. So outside here, we can just write negative y. And then, of course, the order does not matter here at which you write your terms. So we can rearrange these terms here that are within this bracket. We can start with positive x. So we will have x because we don't need to write the positive sign. And then we can follow with negative 1, right? And then we add the x minus 1. And now let me remove this so that this does not look complicated. Okay? And now, as you can already see, we now have got 2 pairs of terms, and these two have got a common factor, which is x minus 1 and x minus 1. So we have x minus 1 in both of these pairs, and so we can take that x minus 1 as a common factor. And after you do that, what are you going to be left with? As usual, you can find what you are left with by dividing. And so we have negative y into x minus 1, and we need to divide by our common factor, which is x minus 1. So x minus 1. So this x minus 1 is going to cancel with that x minus 1. So you are going to be left with negative y. So we are going to open our bracket and then we write negative y. Okay? And we do the same thing with this other term. So for that one, we have x minus 1. We can even include the brackets, divided by x minus 1. And it's obviously equal to 1. So we are going to be left with positive 1. Okay? And now what you can do as your final step is you can rearrange these two terms that are inside your second bracket. So you can make your final answer to look like this. So you have x minus 1 into 1 minus y. Because it is good practice to always start with the positive term and then the negative term. And so this is our final answer. And so I want you to take note of this answer because I'm about to show you an alternative thing that you could have done in order to factorize this expression. So we could actually also group these two terms here in a slightly different way. This is because what you may also notice is that these two terms here, negative xy and positive x, we can also group them together because they have a common factor of x each. We have x here and we also have x here. And so if we were to do that, and also bear in mind that the order at which we write the terms does not matter. And so if we were to do that, we would get minus xy plus x plus the second pair, which will be y minus 1. Okay? And then here, if we take out the common factor, which is x, we will have x and then into negative y, because we'll be left with negative y. We simply divide negative xy by x, which is our common factor. So we are left with what? Negative y. And then if we divide x by x, we will find that we are left with 1. And here we are going to carry this down as it is because there is no common factor. And now again, you will notice that what we have inside this bracket is similar to what we have inside this bracket. The difference is the signs of the terms only. Here we have positive y, but here we have negative y. We have positive 1, we have negative 1. And again, what we can do in order to make these look the same is we can take the negative or negative 1 out as a common factor. And after doing that, we will have negative x outside, right? And then this will now change to a positive y, and positive 1 will change to negative 1. And we have plus y minus 1. Okay? And after this, what we can do is, you may already see, we now have a common factor of y minus 1 and y minus 1 between these two pairs. And so if we take this y minus 1 out as a common factor, so we are only going to be left with negative x here. And for this one, we are going to be left with positive 1. You can do the division as I have shown you before. And now again, as your final step, what you can do is you can rearrange these two terms here so that you start with the positive number and then the negative number. So you are going to have y minus 1 and then in the second bracket you will have 1 minus x, and this is your final answer. And I hope that you did take note of the answer we obtained initially. And now I want us to compare this answer with the answer that we obtained initially. And so our first answer was x minus 1 into 1 minus y. And now the answer that we have just obtained is y minus 1 into 1 minus x. And now you might say that, but these answers do not look the same. But we can actually check whether or not these are both correct by expanding the factorized expressions and see if we can get our original expression back. So for instance, for this one, we can multiply x by 1 and we get x, and then multiply x by negative y and we are going to get negative xy. If we multiply negative 1 by positive 1, we get negative 1. And finally, if we multiply negative 1 by negative y, we are going to get positive y. And of course, the order here does not matter, so we can rearrange these terms and write them in the same order as in the original expression. So we have a positive y. We are going to start with that positive y, and then we follow with the negative xy. And then after the negative xy, we can write the positive x here. And then lastly, we can carry down our negative 1. And as you can see, I have just rearranged the order of these terms that we obtained here. I did not change their signs or their values. And what we get is exactly the same as the original expression that we started with. Let's see if we can also obtain the same result if we expand this bracket. So we can multiply y by positive 1, so we get positive y. If we multiply y by negative x, we are going to get negative xy. If we multiply negative 1 by positive 1, we get negative 1. And lastly, if we multiply negative 1 by negative x, we get positive x. And as before, we can rearrange these terms here. We can start with y, and we are still going to follow with negative xy. But after that, we can start with this positive x and then write the negative y. And we get exactly the same expression. And so we have just proven that if we expand our factorized expression, we are able to get the original expression we started with back. And we have also shown that both of these answers or factorized expressions are correct.